Okay. All right. In your journal, you need to go to your table of contents, and you need to put distance versus time graph. Okay, so we're on page 14, distance versus time graph. Okay, so we'll turn over to page 14. Okay. This is what you need to write right here. Should go about 1/3 of the way down. You need to write basically a definition for distance versus time. A distance versus time graph measures how far two objects are from each other. Often these graphs are used to show the journey that someone makes from home to school and back, etc. Basically, it shows how far an object has traveled in a given time. Distance is the y-axis, time is the x-axis. A curved line means a change in speed. So if it's a straight line, it's a constant speed. If it's a curved line, there's a change in speed. So you need to get this written down for a definition. So I'll sit here for a second and let you work on that. For this, you're going to need graph paper. And I'm going to upload a piece of paper. Actually, it's a problem that you are going to put in the top left corner on the back of page 13. So on the opposite page, be on the back of page 13, you're going to put the problem that I want to upload for you to. If you can't print it off, I understand, you need to draw it. But you need to print it or draw it, one or the other. Okay, I'm going to continue. If this is where you need to stop or pause the video, then that's what you need to do. But I need to continue because I can only upload videos of certain size. So I need to move on with this. Okay. You're going to take a piece of graph paper, cut it so it'll fit, and glue it in the bottom. So ignore what we have here because your graph will be different. So cut you a piece of graph paper, and you need to glue it so it goes from here to the bottom of the page. Let me scroll back out. Sorry, back out, and you'll see what I'm talking about. So this is what mine looks like. So that was one block. This is the second block's work. This was the third block's work. We each did our own scenario to do a graph. So you need to get a piece of graph paper, and yours will just be glued straight in. Whereas I have multiple, you'll have single. So get that cut and glued in. Okay. And once again, I will upload this, and when you do, you'll cut it out, and you'll glue on the back of page 13. So I'm going to close my journal for now. I'm going to put this up. Okay. This is what I need to talk about with you in detail, because you're going to be doing this in math when you come back from fall break time. You'll be working on this in math. This is a concept that you do need to have for science also. Okay. What is a distance time graph? A distance time graph shows how far an object had traveled in a given time. It's a simple line graph that denotes distance versus time findings on the graph. Distance is on the y-axis, time is on the x-axis. Curved lines indicate the speed is changing. So let's look at the example. Here's your distance, and this is your time. They just didn't label the distance in miles or kilometers, feet, or whatever they're using. They just didn't label it. On ours, we're going to need to label them so we can understand a little better. And time, they didn't denote what time they are using. So on ours, we're going to either use minutes, hours, 5 minutes, 10 minutes, 2 minutes, or something. We will label ours. So with this line is relatively, let me get a ruler. put it here. This line is relatively almost straight. So that's showing that there's a rapid speed because you're going very fast, a very great distance over a very short amount of time. Okay? With this one, you went somewhere really slowly at a steady speed. You stayed still, like you stopped at a red light or a railroad track, or you just stayed still for a while. Time progressed, but you didn't go anywhere. Then you return to your start position. So this would be like you leaving home, you're going to the store, you stay at the store for quite a while, and then you return back home. This one is you leave home and you slowly increase your speed. So you're getting faster. So if you were going slower, the line would come the other way. So this one I'll also upload. This one wouldn't be a bad one to print off and put also on the back of page 13. I'll probably do that with my class I just didn't do that with this journal, but this one is a really good one to have handy. Okay. Once again, it's just going to back up our conclusion. If the distance time graph is a straight line, then the motion is uniform. So that's what this is, a uniform. Speed can be calculated using the slope of the graph. I'm not worried about the slope. You'll do that in math. So the next one says slope. Not worried about slope. I'm just worried about you being able to read a graph. So let me get some more pages. I can upload these also, so you can have these handy. Okay, here we go. An airplane is descending to land at the airport. During its descent, it had to fly in circles until the landing was cleared of other planes. Explain what is occurring during each of the segments. Well, here's where the airplane is already in the air, so it's descending, so the line is going down. Here, from B to C, it's flying in circles because time is still continuing to pass, but the airplane's not going anywhere, so it's at a standstill. And then this is where it's descending to land at the airport. So number 2. John left his home and walked 3 blocks to his school. So here's the graph. Time, of course, here, distance here. So that's 1 block, 2 blocks, 3 blocks. So what is one possible interpretation of the section of the graph from point B to C? John arrived at school and stayed throughout the day. John waited before crossing a busy street. John returned home to get his mathematics homework. Or John reached the top of a hill and began walking on level ground. Well, here John left home. He's walked 1 block. He's walked 2 blocks. And it says 3 blocks is the school, so we know D is the final destination school. So as of now, something's happening here that he didn't quite make it all the way to school. So what could be happening here? As we said before, a straight line means that time is moving, but the person is not going any distance. So it has to be 2. He's waiting before a busy street to cross. So he walked, he got to a busy street, he waited to cross the street, and then he went on to school. So it has to be number 2. If you have any questions on this, email me. I'll gladly slow down or go over something again. But guys, you've got to know how to do these. Like I said, I can upload these also. I probably will go ahead and just upload the whole packet. Jen left her house and drove to school in the morning, as shown in the graph. On her drive to school, she realized that she forgot her book bag and had to return home before driving back to school for her 3-hour class. Explain what is happening during part of the graph below. Well, from A to B, Jen was driving to school. She didn't make it to school, so she turned around and went back home at B and C. So C to D, she drove to school, and then from D to F is her 3-hour class. Okay, number 4. Marie's distance from home is A, work is F. So a lot happened between A and F. So A, Marie left her briefcase at home and had to return to get it. State which point represents when she turned back around to go home. Well, it had to be she went from A to B's when she turned around and went back home to C because C is home where she started. So from C to D, she had to wait. That would be B. She waited at the railroad tracks. Then from D to E, before E to F, she proceeded to work. So that is also relatively simple. The last one. A bug travels up a tree from the ground over a 30-second interval. It travels fast at first and then slows down and stops for 10 seconds, then proceeds slowly, speeding up as it goes. Which sketch illustrates it? Well, a bug travels up a tree, so it's going to start at ground point. So we can eliminate this one because it's not starting at ground point. We can eliminate this one because it's already in the tree. We can eliminate this one because it's already in the tree. So it has to be this one. So like it says, it travels fast at first, it slows down, it stops for 10 seconds, and then it speeds back up. So it has to be this one. So we could eliminate those, and that way we could go back and check just to make sure. But this one was easy. Okay, that's the examples I have. So now what you need to do is you are going to create a graph on the graph paper. You might want to do a practice one or two first, but you need to create a graph and you need to either upload it, email it, or somehow get it to me. Now, it'd be lovely, students, if you did it. Don't get your parents to do it. I need you to do this. You either do it, take a picture of it with your phone, email it to me that way, take a picture of it with your Chromebook, get it to me that way. But either way, you might want to do a practice one first and send it to me before we do a final one to get it into your journal. If you have any questions, email me. If you Google distance versus time graphs, you're going to get a bunch of different ones. If you hit images, you're going to see many numerous ones. Don't make this too complex. Let me show you the ones we did in class because we like to pick at the other teachers here. So this is one that we did. Coach Stacy was at a ball game. Let me scroll out a little further. All right. Coach Stacy was at a ball game and needed his coffee. He returned to school the ball game was 20 miles away. He returned to school in 10 minutes to get his coffee. He sat at a red light for about 5 minutes. Okay. So what we did was we labeled time in minutes, distance in miles. So we did 5, 10, 15, 20. We did it in 5-minute increments. So this is what you need to do. Do it in whatever time increments you want to do it in, but you need to label it. So distance, we did 2, 4, 6, 8. We did it in 2-mile increments for the distance. So he started off 20 miles away at a ball game. So we put our dot at 20. And he needed his coffee, so he returned to school in 10 minutes. So he went down for 5 minutes first before he had to sit at a red light. Halfway, it said he had to sit at a red light. So he went 5 minutes, sat at a red light for 5 minutes. Then he went from here back to school for a total of 15 minutes later. So that's how we got our lines on this one. Now, had we have said he stayed at school for 15 minutes, we'd have gone to 30 and returned to the ball game. We would have gone from 30 back up to 20. And it's according to how quickly he got to the game as to where our line would have been straight, arched, or at an angle. Okay, the next one. They like to pick on Miss Perriman. Miss Perriman was at Sonic in Lewisburg because she's from Lewisburg. So she was at Sonic in Lewisburg when she realized she forgot her speaker. She drove home and then drove to school, sat in her car for 15 minutes before going inside. So she started at Sonic in Lewisburg. So she's on 2. Once again, they went 2, 4, 6, 8, 10, 5, 10, 15. So be sure you label the distance in miles, time in minutes. She was at Sonic. It took her 10 minutes to get home. And then from there, it took her 15 minutes to sit in her car. It took her that long to get to school. They said 15 minutes. Yeah, she drove fast, apparently. And then she sat in her car 15 minutes before going inside. So that's how this graph came to be. So the next one, they're picking at Miss Lightfoot, who happens to be pregnant at the time. So Miss Lightfoot is at a softball game. So here she is down here at a softball game. And they did it by 1 mile increments because we're staying in Chapel Hill this time. So she was at a softball game when she felt a labor pain. She rushes to her car and drove to the All About Animal Vet Clinic in a hurry. So she went from here to 2 miles away in 5 minutes. So 5 minutes, 2 miles away. That was our first line. She stayed there for 15, let's see, 5, 10, 15 minutes. She stayed there for 15 minutes. Then she returned to the softball park. Then she drove from there home. Then we could say she stayed at home for a while. It would be a straight line, and then went back to the ballpark. Would be another line down. So that would be another extension. So this is what you need to come up with. You need to come up with a scenario, make your graph, label it, and identify it. Don't make anything fancy. In other words, don't get it off the internet. I need to see a scenario that we can understand. Stay within Chapel Hill, Lewisburg, or something rather simple. Don't make this too complex. Email me any questions that you may have.